On October 19, 2025, the International Orbital Tracking Consortium confirmed something no gravitational model had predicted. The interstellar object 3IATLAS performed 2 trajectory corrections in less than 48 hours. The first maneuver occurred at 3:14 UTC on the 17th. The second at 2:51 UTC on the 19th. Meanwhile, the Harvard Space Dynamics Observatory held back for 72 hours perturbation models that could explain the phenomenon. Not a delay of hours, 3 full days of institutional silence, while telescopes around the planet recorded something unprecedented. Think about it. An object traveling at 87 kilometers per second through the interstellar void does not simply change direction twice in 2 days. Rocks don't turn. Comets follow predictable orbits dictated by gravity. So what is happening with 3IATLAS? And why did one of the world's most respected institutions take so long to share data that should have been public immediately? Because what we are about to unpack here might be the most important astronomical observation of your lifetime, and time to understand is running out. Almost double the distance between Earth and Mars when the planets are at their closest. The object travels at a speed of 87 kilometers per second. Convert that to units that make sense in your daily life. 194,000 miles per hour. Fast enough to cross the distance between São Paulo and New York in 32 seconds. The trajectory also draws attention. Orbital eccentricity of 1.19. Any value above 1.0 signifies a hyperbolic trajectory, something that comes from outside and will never return. The object is just passing through, but there's more. The ecliptic inclination angle is only 1.7 degrees. For a body supposedly coming from another star, traversing the galactic plane at a random angle, this near-perfect alignment with the solar system's plane is statistically improbable. Think of throwing a tennis ball from the top floor of a skyscraper and hitting a coin on the ground. That level of improbable. The WISE 2 satellite, an infrared telescope in polar orbit, captured the object's thermal signature in the second week of October. WISE 2 measures infrared radiation, the heat all celestial bodies emit. The hotter, the brighter in the infrared range. What it detected was this. The face of 3IATLAS, exposed to the sun, registered 310 Kelvin. The opposite side, shielded from direct sunlight, measured only 140 Kelvin. This represents a difference of 170 Kelvin degrees between hemispheres of an object that should be rotating and gradually balancing its temperature. This represents a difference of 170 Kelvin between the hemispheres of an object that should be rotating and gradually equilibrating its temperature. What the data showed was a periodicity of 6.02 hours, but not just any periodicity. The standard deviation over 11 days of observation was a mere 0.003 hours. This is a precision of 10 seconds maintained for over a week. It's the kind of stability you see in artificial satellites with attitude control systems, not in chaotically tumbling space rocks. Lena Prokovich from the Austral Institute of Orbital Dynamics summarized it this way. Natural asteroids and comets exhibit what we call tumbling, an irregular rotation caused by impacts, asymmetric outgassing, and accumulated gravitational torques. What 3IATLAS presents is stabilized rotation. This does not align with the natural history of an object that has traveled thousands of light years through interstellar space. The Atacama Radio Astronomy Complex, a network of antennas listening to the universe at radio frequencies, detected continuous emission at 1.42 gigahertz. This is the hydrogen line, the natural frequency at which hydrogen atoms emit electromagnetic radiation. It's one of the most common signatures in the cosmos. Interstellar gas clouds glow at this frequency, but 3IATLAS is not a gas cloud. It's a solid object, and the signal showed a 0.8% modulation with each complete rotation of the object. This rhythmic modulation has never been documented in a comet or asteroid. Never. Anomaly 1. Extreme thermal asymmetry. When an object rotates in space exposed to sunlight, the rotation distributes the received heat across its entire surface over time. It's like turning a rotisserie spit over hot coals. Even if one side receives direct heat for a few hours, the other side would have already been warmed in the previous cycle. The temperature difference between hemispheres on a typical asteroid ranges between 20 and 40 Kelvin. 3IATLAS exhibits a 170 Kelvin difference. This would only be possible if one face were actively being heated or cooled, or if the albedo, its ability to reflect light, were radically different between the two sides. Think of a mirror on one side and charcoal on the other, but this does not happen with space rocks. Anomaly 2. The precision of rotation. Natural objects in space do not maintain such exact periodicity. Each jet of gas expelled by a comet causes a tiny torque that alters the rotation speed. Every escaping dust particle changes the angular momentum. Over days, these changes accumulate. The rotation speeds up or slows down. The period varies, not with 3IATLAS. 6 hours and 2 minutes repeatedly with a variation of less than 10 seconds. This demands either a perfectly symmetrical geometry, which is geologically impossible, or some stabilization mechanism. 1 minute and 2 seconds, repeatedly, with a variation of less than 10 seconds. This requires either a perfectly symmetrical geometry, which is geologically impossible, or some stabilization mechanism. Rocky bodies do not emit radio signals. They can reflect electromagnetic waves, but they do not generate their own emission at that frequency, much less in a modulated form, synchronized with rotation. Dr. Emilio Vargas from the Andean Radio Astronomy Center commented, "It's as if there were a point source on the object continuously emitting, and as it rotates, our line of sight detects variations in intensity. This has no analog in any known cometary phenomenon." Anomaly 4, the trajectory corrections. At 3 a.m. UTC on October 17th, tracking stations on 3 continents registered a subtle but unequivocal change in 3IATLAS's velocity vector. It was not a gradual acceleration. It was a discrete, instantaneous alteration in the telemetry records. 48 hours later, another correction. Comets can alter trajectory when they expel gases, a phenomenon called the non-gravitational rocket effect. But these jets are visible. They leave trails of gas and dust that glow under sunlight. 3IATLAS exhibits no coma, the gas cloud that surrounds active comets. There is no tail. There are no observable jets in the visible or ultraviolet spectrum. Interstellar objects should arrive from any direction with randomly distributed inclinations. The probability of an object coming from deep space aligning so perfectly with the plane of the solar system is less than 1%. Not impossible, but improbable enough to raise eyebrows. If you add the trajectory corrections to this alignment, the combined probability drops to less than 1 in 10,000. If it were natural outgassing, we would expect mass loss and consequent detectable deceleration. We did not observe that. The object maintains its 87 kilometers per second. It's as if the maneuvers were calculated to alter direction without a speed cost, something that requires extreme energy efficiency. 3IATLAS was detected at exactly the ideal moment for detailed observation before perihelion. Any earlier, and it would have been too far for high-resolution imaging. Any later, and the orbital geometry would have made continuous tracking difficult. The maneuvers occurred precisely when the object was under maximum surveillance from multiple observatories. Coincidence or not, it's impossible not to notice the almost orchestrated timing of events. Perhaps the sensors are calibrated incorrectly. Perhaps there's noise in the data that we're interpreting as a real signal. But 3 independent systems, in different hemispheres, using distinct technologies, all registered the same anomalies. WISE 2 uses infrared sensors. Pan-STARRS uses CCD cameras in the optical spectrum. The Atacama complex uses radio antennas. For it to be instrumental error, all 3 systems would have to fail in exactly the same way at the same time. That is not likely. That is improbably coordinated. For it to be instrumental error, all 3 systems would have to fail in exactly the same way at the same time. That is not probable. That is coordinately improbable. If 3IATLAS has pockets of crystalline carbon monoxide or other exotic chemistry concentrated in one region, this could cause directional jets that would explain the maneuvers and thermal asymmetry. But then, where are the jets? Why has no telescope detected ultraviolet emission characteristic of excited CO molecules? Why does the radio modulation persist? Outgassing does not generate modulated radio frequency signals. The human brain excels at finding order in chaos, but computational models have confirmed the periodicities. Anomaly detection algorithms, designed to filter out exactly this type of bias, flagged 3IATLAS as an outlier across all tested parameters. 4th explanation, gravitational lensing or dark body perturbation. Perhaps there is an invisible mass, an undetected dwarf planet, or even a small primordial black hole distorting the object's trajectory. But to cause 2 discrete corrections within 48 hours, this dark body would have to be positioned with surgical precision in 3IATLAS's path and exert gravitational force within extremely short temporal windows. Furthermore, gravitational lensing does not explain radio emission or active thermal asymmetry. So let's move on to the uncomfortable. What if 3IATLAS is neither a comet nor an asteroid? There are other possibilities that do not involve invoking extraterrestrial intelligence, yet still challenge our current understanding of astrophysics. One of them, active cryovolcanism fueled by internal radioactive decay. If the object has a nucleus rich in long-lived isotopes, residual heat could maintain liquid pockets beneath the surface and cause directional eruptions. This would explain the thermal asymmetry and perhaps even the maneuvers. But it does not explain the precision of its rotation or the radio emission. Magnetic fields interacting with the solar wind could, theoretically, generate electromagnetic emissions. But modulation synchronized with rotation would require extremely specific field geometry, something that would not survive intact after thousands of years of interstellar travel. And then there's the hypothesis nobody wants to say out loud, but which the data makes plausible: a technological artifact, not necessarily active, perhaps a fossil, an ancient probe launched by a civilization that ceased to exist millennia ago, still following residual programming, or a damaged interstellar habitat structure, spinning in the void with degenerate power systems emitting faint signals. The precision of its rotation would make sense if there were gyroscopes or reaction wheels on board. The radio emission could be leakage from ancient transmitters. The maneuvers could be automatic course correction attempts executed by an onboard computer still responding to solar sensors. The maneuvers could be automatic course correction attempts performed by an onboard computer that still responds to solar sensors. The difference between advanced technology and a natural phenomenon can be indistinguishable at a distance if we don't know what to look for. Occam's razor tells us to prefer the simplest explanation, but when all simple explanations fail, we are forced to consider the complex ones. Hassan Al-Fayed from the Arabian Center for Transient Object Studies was cautious but direct. I'm not saying it's artificial. I am saying the data doesn't fit any known natural category. If we are rigorous with the scientific method, we need to test the hypothesis of artificiality with the same seriousness that we test exotic volcanism or unknown chemistry. To discard a possibility before investigating is dogma, not science. It's not the possibility of 3IATLAS being artificial. It's the institutional silence. Harvard took 72 hours to release the perturbation models. The International Orbital Tracking Consortium issued a dry technical note confirming the maneuvers, but without interpretive analysis. No top-tier university published a preprint about the radio emissions. The standard scientific protocol for discoveries of this magnitude is immediate transparency and parallel peer review. Raw data goes to public servers in hours. Here, we have an unofficial embargo. 1. Institutions are being cautious not to spread panic or premature speculation. It's understandable. The memory of Oumuamua is still fresh, when alien solar sail hypotheses dominated headlines and created noise that hindered sober analysis. Perhaps astronomers are waiting to have solid models before facing the media circus. That would be responsible. Something that changes the game completely. I'm not suggesting a conspiracy, I'm pointing out a pattern of behavior. When the scientific community breaks transparency protocol, there is usually a specific reason. Sometimes it's to protect a patent or discovery. Sometimes it's to avoid public alarm until certainty. And sometimes it's because what they are seeing challenges such fundamental assumptions that it requires extreme validation before an announcement. 91 astronomical units from the Sun. After this passage, the object will accelerate beyond 120 kilometers per second, boosted by the gravitational slingshot effect. In weeks, it will be beyond Mars' orbit. In months, beyond Jupiter. And then it will disappear into the interstellar void forever, accelerating to speeds that make interception impossible with current technology. 18 days to point all available telescopes at this object and extract every possible photon of information. If there are surface structures, if there are artificial symmetries, if there is any detail that confirms or refutes artificiality, it needs to be captured now. Every photon of information. If there are surface structures, artificial symmetries, or any detail that confirms or refutes artificiality, it needs to be captured now. If 3IATLAS performs more maneuvers near perihelion, particularly those not matching predicted outgassing, the artificiality hypothesis gains dramatic weight. Conversely, if the object starts exhibiting visible gas jets and its thermal anomalies stabilize, we might be witnessing a new class of interstellar comet with truly alien chemistry from a differently composed star system. Either scenario would rewrite astronomy. If nothing else happens, if the object simply passes through perihelion and accelerates outwards without further surprises, we will still have learned that the universe produces phenomena our models do not predict, and that is valuable. Not necessarily aliens, but certainly new science. But what if it's none of that? What if we are observing the last detectable interstellar technological artifact this century and let it pass due to excessive caution or lack of coordination? Think of the opportunity cost. If there's a 1% chance it's extraterrestrial technology, and we don't mobilize all resources to confirm, what future generation will forgive us? A rapid response protocol includes redirecting non-critical space telescopes for continuous observation of 3IATLAS, coordinating global radio telescopes to search for broadband signals beyond the hydrogen line, interferometric imaging using multiple synchronized telescopes to resolve surface details, intensive spectroscopic analysis to identify precise chemical composition, and trajectory modeling updated every 6 hours to detect further deviation. Publishing all raw measurements on an open server so astronomers worldwide can contribute with independent analysis. Science works best when 1,000 different brains tackle the same problem from different angles. Institutional secrecy, even well-intentioned, hinders progress. Then there's interception. Space missions take years to plan and launch. But 3IATLAS presents a unique window. It is entering the inner solar system, where a conventional probe flyby is still possible. Its speed is high, but not impossible. For comparison, New Horizons traveled at 16 kilometers per second past Pluto. 3IATLAS is at 87 kilometers per second, yes, but a trajectory well calculated with Jupiter's gravitational assist could, theoretically, position a probe for a close encounter. Launch must happen in weeks, not months. This means an already on-pad rocket, minimal payload, maximum risk. The probe would not reach the object before perihelion, but it could cross its trajectory after it accelerates outwards, capturing high-resolution images, measuring magnetic fields, if any, perhaps even collecting leftover dust particles. It's an extremely high-risk mission with moderate success chance. But if there's any possibility of confirming artificiality, the cost is worth it. However, if there is any possibility of confirming its artificial nature, the immense cost would be entirely justified. However, ESA has its Vega rocket in preparation, JAXA has rapid flyby technology, proven with asteroid missions, NASA has real-time data analysis capabilities, and private consortia like SpaceX could provide launch platforms at a reduced cost. If there was ever a moment for global cooperation in space exploration, it is now. Either we confirm that 3IATLAS is an extremely rare natural phenomenon that will expand our understanding of cometary astrophysics, or we confront the possibility that we are not alone and that the universe is more populated with technology than we ever imagined. Both conclusions compel us to rewrite entire chapters of science. Both are, in their own way, terrifying and marvelous. In 18 days, 3IATLAS will begin to accelerate beyond our reach. When it crosses Neptune's orbit 2 years from now and starts to fade into the darkness of deep space, we will either have answers or we will simply have bigger questions. And perhaps, just perhaps, we will look back and realize that this was the moment the universe winked at us and we almost missed it. This is not a work of fiction. It is observational data. It is real. And it is happening now above our heads as you read this.